Hi guys, hope you're having a good day. Sorry I couldn't be there today. Um, we're going to go through the next couple of topics. The first one is going to be the antiderivatives of e to the x. Now, I actually forgot to include this in your workbook. So if you just want to find a page at the back, I'm pretty sure there's a notes page for you. And I'll get you to copy down this rule. So the rule for integrating e to the x is that the integral of e to the x dx is just e to the x divided by whatever the derivative of the inner function is. So this is very similar to our trig, where we're just undoing a derivative. Because remember, if you differentiated, if you had y equals e to the 3x, the derivative of that would be 3e to the 3x. So the e never changes. The only thing that happens is the coefficient of the x will drop down. Or in other words, you're timesing by the derivative of the inner function. And the derivative of my inner function there is 3. So the same thing holds here, where to undo a derivative, we divide by the derivative of the inner. Excuse me. And then, of course, plus c. Now, this is important. K cannot equal 0. It doesn't work when k equals 0. So let's have a quick go at solving some of these guys. They are pretty easy. So our first one is our function is equal to the integral or the derivative of e to the 4x. So that's just going to be equal to, the e to the 4x is going to stay exactly the same, but we need to divide through by the derivative of the inner function, which in this case will be 4. So you can write that as 1/4 times e to the x. You could write that as e to the 4x over 4. I prefer the second one. Both are correct, but yeah, it's up to you which way you want to write that. Okay, let's have a look at b now. So, I have realized I forgot my c. Plus c, c. Let's have a look at b. So we have the derivative of e to the 5x plus 6x dx, and we want to integrate that. So that's going to be equal to e to the 5x is not going to change. It is set in stone. However, we do need to divide by the derivative of the inner. The inner function is 5x. Derivative of 5x is 5. So that becomes e to the 5x on 5. We have this separate term over here, 6x. Now remember that when we have a separate term, we integrate it separately. So that just becomes 6x squared, and we divide through by the new power 2. Then plus c. So if you wanted to clean that up, you'd have e to the 5x over 5 plus 3x squared plus c. Okay. Next one. Derivative of... I said derivative last time as well, didn't I? Integral of e to the 3x plus 2 dx equals... e to the x doesn't change, so that stays as e to the 3x, but we divide by 3. When you integrate 2, it has no x term, so that means an x term basically gets added onto it. Plus 2x. Plus that constant of integration. None of these questions are actually asking us to solve for the constant of integration, so we don't need to worry about it. Okay, last one. Integral of e to the negative x plus e to the x dx, to tie that off. Integral of e to the negative x doesn't change. And we divide through by the derivative of the inner. The derivative of negative x is actually negative 1. So on the next line, that's going to be negative e to the negative x. Up here, e to the x stays as is. So plus c. That's it. Done and dusted. We cannot do anything with these two. Like, we can't say, oh, that's negative e, that's positive e, let's cancel them. We can't do that because they actually have different powers. This one's a negative x, that one's a positive x. I suppose if you wanted to, you could rewrite that one as negative 1 over e to the x. If you wanted to have it a bit nicer, but you don't need to go to that final step. I wouldn't worry about it. And guys, that's all there is to derivative of e to the x. They're literally the most simple one, which is probably why it got overlooked to include them in the workbook. I will give you some questions to look at here. There are some questions on page 358 of the textbook. Question 1, 2, 3, 4. So 358, 1, 2, 3, 4. I don't need you to do them right now because I'm going to show you the next thing. But once we get into textbook work, I'll get you to have a go at those questions as well. So, let's just recap actually quickly. We now know how to do e to the x. We know how to do a general polynomial. We know how to do a general power function. We know how to do trig functions, sine and cos. We're now going to look at doing functions like this. So I've called this, antiderivatives of ax plus b to the power of r. I'm hoping you recognize this as being chain rule. We have an inner function, ax plus b. We have an outer function, bracket to the power of r. So basically what we're going to be doing here is opposite chain rule. So we're learning how to undo chain rule. If you recall chain rule, it's the derivative of the inner times the derivative of the outer. So what we're going to be doing is we're going to be integrating the outer function, and then we're going to be dividing by the derivative of the inner. And that'll undo the chain rule, because we are doing anti-derivatives. So if I start with my function, ax plus b to the r, what I do is that basically stays as is, but you add 1 to the power. You divide through by the new power. So you divide through by the new power. And you also divide through by the derivative of the inner function as well. And in this case, the inner function is ax plus b. So let's do some of these in practice. It's a bit of a complex one, these ones, so that's why I like to just get stuck straight into practice. I will note, though, guys, these don't work if your power is negative 1. So if your original function is ax plus b to the power of negative 1, or 1 over ax plus b, this won't work. There's a special case for that, and we'll get to that in a couple of minutes. Okay, so let's find these antiderivatives, guys. We have a. We want to find the antiderivative of 3x plus 1 to the power of 5. Okay, so let's have a look here, guys. If we look at our rule, the rule's a bit complicated. It's got that 1 over at the front. But if we look at the ax plus b part, it doesn't actually change. the power changes, it goes up by 1. So let's do that bit first. So we're going to have 3x plus 1 still in our brackets, and it's going to be to the power of 6. In front of the brackets, we'll then divide through by that negative power, so, that a. So we're dividing through by 6, and we're also, underneath that fraction, we're timesing through by the derivative of the inner. And I just realized I highlighted the wrong thing there. How embarrassing. Should have highlighted that one in purple. So that should be 1 over 6. And then I times through by the derivative of my inner function, which is 3. And of course, this is an indefinite integral, which means we add plus c on the end for the constant of integration, which if we tidy that up, guys, we should get 3x plus 1 to the power of 6 over 18 plus c. I actually prefer to go straight to I don't like having this 1 over at the front. I prefer to just put the stuff straight on the bottom. And that's what we're going to do for this next one, guys. Okay, so let's do the next one. Oh, sorry, I meant to say we are on page 24. Okay, so the integral of 2x minus 1, that should be. Okay. Sorry, my screen's even more broken than before, so I can't lay my laptop flat. It's causing some issues. 2x minus 1 to the negative 2 dx equals. So remember, guys, my bracket is unchanged, but I add 1 to the power. So I'm going to have bracket 2x minus 1, close bracket. I'm going to add 1 to that power. So negative 2 becomes negative 1. Okay? Then I divide through by that new power, so negative 1. Then I also divide through by the derivative of the inner function. So the inner function is 2x minus 1. The derivative of that is 2. So I just do times 2. Now, just in case you're a bit confused, when I say I'm dividing through by the derivative, but then I write times 2, the reason I'm timesing 2 is because there's already something on the bottom of the fraction. Okay? It ends up being the same thing. If I had this over negative 1 and then I did over to the right, divide by 2, that's the same thing as timesing 2 on the bottom of the fraction. I'm skipping out the middle step is why we're going straight to divide by 2 on the bottom. Now, of course, once again, I have forgotten to plus c. Now, looking at that, guys, it's not in the perfect form because we have this negative 1 and the 2 that can be simplified into negative 2. And we have this has a negative power, so I can probably bring that down the bottom of the fraction. So this negative 1 times 2 is negative 2. I actually want to put the negative out the front of the brackets. So I have 2 on the bottom, and I'm just going to bring this bracket down to the bottom of the fraction so that we get rid of that negative power. That'll leave a factor of 1 on top, and on the bottom, 2x minus 1 plus c. There's no more power there, guys, so if you wanted to, you could times through by that 2 and get negative 1 over 4x minus 2 plus c. I don't care to do that, though, so I'm not gonna. Cool. Hoping that makes sense. Let's look at some more problems, guys. So determine f of x if f dash of x equals the square root of 3x minus 5 to the power of 5, and we know that the original function passes through the origin. Okay, so f dash of x equals the square root of 3x minus 5 to the power of 5. So therefore, f of x, if my derivative equals that, to get back to my original function, I take the antiderivative, which would be the integral of square root of 3x minus 5 to the 5 dx. Once again, apologies that it's a bit messy today. I can't put my screen down, so I'm writing on it while it's vertical. Now, like I said, we're combining this with stuff we've looked at before, and I'm hoping you'll remember that a square root sign is something for grade 3s. We all know that a square root really means to the power of a half. Because this bracket is already to the power of 5, if we combine that with the square root, that means we're actually finding bracket 3x minus 5 to the power of 5 halves dx. So all I've done is I've taken that square root sign, I've resolved it as the power of a half, and I've combined it with the power of 5 that's already there. So integral of bracket to the power of 5 halves. Okay. So let's integrate. So we know that that bracket is going to stay the same. 3x minus 5. We're going to add 1 to the power. If we're adding 1 to the power and it's over 2, the easy way to do that in your head is just add 2 to the top number. So in other words, we're adding 2 over 2. 2 halves to that, which is 1 whole, which would give us 7 halves. Now that we've done that, we need to divide by the new power and divide by the derivative of the inner. Now I'm going to cheat here. I'm not cheat, I'm just going to do it a slightly different way. I'm going to put the derivative of the inner on the bottom. So the derivative of the inner is 3. And I'm going to divide by the new power over here. It should make sense why I do that in a second. Oops, I don't know why I'm writing a plus. I want to write... Sorry, I don't know why I'm writing times. I want to write plus c. The reason I did the divide by the fraction over on the right-hand side instead of chucking it straight under is because it'll make it easier when we do this. I'm going to inverse the divide to become multiply. And I'm going to inverse the 7 halves to become 2 over 7. And plus c stays as is. And that gives me 2 bracket 3x minus 5, 7 halves over 3 plus c. And that's my f of x. And we know f of 0 equals 0. So therefore 0 equals 2 bracket 3 times 0 minus 5 to the 7 halves over 3. Now, I don't have my calculator up on the computer, so I'm just going to have to do this one off to the side. So I just... so let's just put that fraction in my calculator. 2 bracket 3 times 0 minus 5 close bracket to the power of 7 over 2 divided by 3. A non-real answer. Oops, I have set up this problem poorly. The reason that is happening, guys, if you have a look inside my bracket, we have -5, so that'll become 0 minus 5, which is -5. You then, because remember the half, the divide by 2 and the power means square root, you're actually going to be trying to square root a negative number, which is impossible, unfortunately. So what I will just say there is C equals undefined in this case. Sorry guys, I try not to put those ones in, but obviously made a miscalculation when I was writing that question. So yeah, we're just going to pretend C doesn't exist. What a great solution. So our final answer is f of x equals 2 bracket 3x minus 5 to the 7 halves over 3. Yeah, my apologies for that, guys. We shouldn't be giving you undefined answers. You won't get that at an exam or anything, so don't stress too much about it. Okay. Last bit we're going to go through, guys, is the special case. So remember I said that if your R value, so the power is -1, you get a divide by 0 error. It won't work. So if you remember back to when we were differentiating, the derivative of ln x was 1 over x. So we can sort of work backwards and say, okay, well, the integral of 1 over x is ln x. And we should be able to see that 1 over x is very similar to that. So we can sort of work backwards to come up with this rule, which is that the integral of 1 over ax plus b is equal to 1 over a ln ax plus b, and then plus c, as always. So let's follow our rule. And we have 2 over 3x minus 2. If we match this up with our rule, the rule it has 1 over. In this one, it has 2 over. Now, that, I hope you remember, if you have a constant, like that 2 is just a constant, you could really, if you wanted to, and don't write this down because I don't want you to do it this way, you could pull the 2 out the front of your integration, and that would be left with 1 over 3x minus 2 dx. Those two things are equal to each other. So even though there is that constant value on top, guys, we're just going to treat it as if it was a 1 in terms of solving. I'm not a big believer in pulling it out the front because I think it's more work. I just like you to remember that there is that equivalency there. So aside from that, guys, everything else is pretty much exactly the same as the rule. Instead of A, we have 3. Instead of B, we have -2. And we can just sub that into the rule as it's given to us. So 1 over A would be 1 over 3. And then we're timesing it by ln. Now, what's in your brackets is just going to be the same as what's underneath your fraction. So it's going to be 3x minus 2. And then plus the constant of integration. Okay. I literally just went to ask any questions before I remembered that I'm sitting in a staff room by myself. So if you have any questions, ask Sky. She will answer your questions for you. Okay, let's have a look at these ones, guys. 3 over x given the known point 1, 10. So the integral of 3 over x dx, that will be 1 over 3 ln bracket x dx. And we know the known point 1, 10. So we know that if we sub in 10, oh, whoops, I wrote dx instead of c up there. The day's getting to me. 1 over 3 ln of 1 plus c. So if I put 1/3 ln1 into my calculator, 1/3 ln1, 0. So 10 equals c. So therefore, the integral of 3 on x dx equals 1/3 ln x plus 10. Okay. Last one, guys. My function is equal to the integral of 2 on 1 minus x dx, which is 2 over... Oh my god. I just realized the one at the top should have a 2 over it. Okay, so it'll be 2 over a. Now in this case, my a, so my derivative of my inner would be -1, which then leaves us with ln bracket 1 minus x, close bracket, plus c. And we can see at the front here that 2 over -1 can be simplified to -2 ln bracket 1 minus x plus c. And then it wants us to sub in the known point, f of 1 minus e equals 5. So we have 5 equals -2 ln bracket 1 minus bracket 1 minus e, close bracket, plus c. Put that into the calculator. -2 ln 1 minus bracket 1 minus e. Now in your calculator, you can't just put e in. It'll ask you for e and then a power. And because we only just want one lot of e, we just put e to the power of 1. Now, that ends up being -2. 5 equals -2 plus c, plus 2 to both sides. C equals 7. So therefore, f of x equals -2 ln 1 minus x plus 7. Cool. Guys, I'm going to leave those two for you to have a crack at. And then I want you to have a crack at page 356, question 2, 3, and 5. And I will end the video there. Good luck, everyone. And remember, for all of your questions, ask Sky.